ready, Jeff? Ready?
Check, check, check.
All right, good. Okay, so our ultimate presentation of the day, Mr. Bill McLaughlin with EEG. We'll talk about automated captioning, which is a really big thing. It's happening, and I know a lot of broadcasters are really excited about this. So I'm very intrigued to hear what you have to say. Take it away, Bill.
Thank you. Yes, our last presentation of the day, and we'll be dealing with ancillary data in 211040 and specifically closed captioning. Like a lot of broadcasters, it's going to be the last thing of the day. We're going to get the video online, we're going to get the clock online, we're going to get the network online, we're going to get the audio online, and finally we're going to get closed captioning online, which in so many countries is a legal requirement. So it's going to come online, and we need to do it in 2110. So let's talk about how. I am the VP of Product Development at EEG, so I have been involved pretty intimately in the development of all of our current solutions, from automatic captioning workflow to captioning that's human assisted, and all the captioning into 2110 that we are now doing with our Alta product. And that will work over the same networks that EEG has been passing captions from human assisted and automatic sources on for many years, which is ICAP. So we'll talk about how the 211040 standard works and how it's different and not different from things that you're doing in SDI, and what kind of improvements doing a native 211040 insertion will have over using SDI equipment in some kind of hybrid workflow, or using SDI to IP gateways, and how it changes workflows and some different ways to think about ancillary data once it's become a multicast in the IP space and maybe is not so much constrained anymore by the traditional things that you would be doing in VANC, even moving beyond the 211040 standard. So a review, if anyone hasn't seen other presentations today, in 2110 we're going to take our SDI signal that is multiplexed, or our 2022 signal that is essentially the entire video, audio, and any ancillary data and other data, and that's all going to be together in one stream, essentially time multiplexed. We're going to break those streams apart so ancillary data becomes its own stream, and it's synchronous according to the PTP timestamps in each RTP packet with video and audio. But it's its own stream, it's its own multicast on the IP network, so each receiving device can make its own IGMP join of only an ancillary stream, or you can be joining video and audio in an ancillary stream, all coming from the same sender that were once part of the same program, or that are being joined into being the same program. On a packet level, each of the 211040 packets is going to, it has this typical RTP header. It has some additional information specific to 211040 that describes the packet on the video frame level. Is the video, is it an interlaced frame? Is it a progressive frame? How many packets are going to be in the frame? And then for each of the packets, it has reconstruction data to put this into SDI. So the key point here is that these 211040 packets have all of the information that would be in an SDI VANC packet, and really not more or less, because the standard is designed so that it's completely interoperable into and out of SDI VANC. Each packet has a place where you can put it in SDI that needs to be unique compared to other ancillary packets, and it has a did-SDID that's the same as the ones defined in SDI. So, for example, captioning is probably our most common ancillary packet. There's time codes and things like that, and video payload IDs that are also very important. Some form of captioning and subtitling is going to be required on a lot of live broadcasts. And the standards that you'll use in 211040 are going to be the same standards that you've really already been using in SDI. So there's different standards in different regions, and that reflects the fact that by the time you come all the way down to the viewers on something like a set-top box, you generally have a government mandated standard specific to that region that the set-top boxes are going to read. So that manifests itself in different production standards we'll mostly be talking today thinking about either the American and Canadian, Korean SMPTE 334 VANC packets carrying 608 and 708 data, and the OP47 packets which carry DVB teletext data. So because these standards are the same, and because there is this direct relationship between SDI ancillary data and 211040 data, you'll be able to take an existing SDI captioning product. You would be able to use general purpose IP gateways that take the video, the audio, and the ancillary data together, embed them and disembed them in and out of SDI, and you would be able to take your existing caption encoder and wrap it in those. Again, that's because we haven't defined a new standard at this point for how we're going to carry the data. We're carrying the traditional payloads, we're just carrying them over IP. Now, there's a lot of good reasons you wouldn't want to do that. Probably the simplest thing to see is if you're doing a native software-driven 211040 data for, say, captioning, and that's translation, so you can have 211030, which is the audio payloads, going into a caption device that's going to convert that into a transcription and make the text data that's 211040. And what you notice isn't in the figure is the 211020 video payload data. So since you don't have the video payload data, you've shrunk the bandwidth of the streams going in and out of this product by a factor of over 100. So you've had the lower bandwidth signals coming in something that wasn't captioning and subtitling, something that was generating, for example, SCSI trigger packets. You wouldn't even need the 211030 input. So effectively on a conventional server, you can put an almost unlimited number of channels of the 211040 data because the bandwidth is so small compared to the video data and compared to what's going to be available on each of your switch ports. This sums up kind of the differences between what you would be seeing if you thought about captioning into a stream where you're captioning the whole stream put together, into the video, whether that's SDI or something like 2022 or even 2110, assuming you had to route all of the packets together, which you of course don't, because you can only join the audio that you need. You can send out the ancillary that you need, and at this point you have, in 2110 native, you have a virtualization-friendly solution, and the solution is basically all in a server, and you're using about 1 megabit per second or less to put out all of the ancillary data per channel. Again, pretty much unlimited density of the ancillary products. The only thing you need to do is make sure you're inserting them into the network in sync with the video so that other products that are receiving it are going to be able to put the whole package back together in a clean way. So let's take a step back specific to captions to understand how this application is going to work and ask, where do the captions actually come from? And in a very zoomed out way, what you're dealing with is an asynchronous time domain with pretty much a very low bandwidth and relatively bursty data source, because you're having a transcription of speech, and the transcription of speech, whether that's coming from a human stenotypist or a human voice writer or an ASR system, is coming out about a syllable, a word, a sentence at a time. And so on the scale of video frames, this data is only coming out every couple of seconds. There may be no significant data for periods of 5 or 10 seconds, but as we packetize this into 2110, we need to keep up that frame drumbeat to keep synced with the video. So the 211040 caption encoder really is taking the timing of this data and moving it into the 2110 domain so that it's usable with video. Once the captions are out there, you actually also have an additional savings, which is that now that they're in a multicast that's synced with all of the house video based on the PTP clock and the prevailing video frame rate, you can take that multicast, you can join it from multiple different points, and you can route the same captions literally to different multi-viewers or to different production endpoints, where this is something that in the past you might have had to actually stamp the ancillary data separately onto many channels of video. Now it's one transmit stream, and the different receivers can join it through IGMP. There are some capabilities in some of these products for receiving and transmitting ancillary data that are kind of different from what's available in SDI, and that's what this slide is going to show. What you see in the diagram is that we have a simple and a complex architecture for both a transmitter and a receiver of ancillary data. And what I mean by simple and complex is that the complex architecture can handle the fact that there are, on one hand, a lot of different DIDs and SDIDs that all could be coming from different expert devices, which are the simple transmitters here. And so you have these different applications that are logically separated from each other and could be coming from very separate devices on the network that are just experts in their own packet type. Now, receivers might be able to receive all of these different multicasts and be able to assemble them back for a suited purpose. However, this complex receiver that can do that might be constrained in what it can do with different of these transmitters. For example, if you're going down into SDI, you could have problems if not all of these packets if they have overlapping line numbers, if they're being told to reconstruct into the same place, or if they're a type of packet where it isn't sensible to have two different values on the same video frame. Essentially, there is no arbitrator in this simple transmitter complex receiver architecture that's clearly going to be able to know what to do with packets from a different device. Conversely, if we look at the other diagram, you see a more complex set of transmitters because each transmitter works more in series the way an SDI ancillary inserter would have to. Each one takes the multicast of a device upstream of it, essentially repeats that packet, and also puts in the packet an additional DID-SDID. So you're building up multicasts that have progressively more data types, each in a single multicast. And that creates more complexity in each of these transmitters, which is now also a receiver and a repeater. However, it means that when you end up at an end receiver, you can be looking at a product that only needs to take one multicast for ancillary data, and at that point, that one multicast can be said to just be either coherent and correct or not coherent and correct. And a lot of products that are on the market today actually look more like this simple receiver, that they have an ability to take a single multicast that's coded correctly and do one deterministic thing with that. You can picture a kind of bridge device as well, and this is kind of equivalent to a side keyer in video, where you have a device that essentially takes all of these different multicasts and is going to legalize and regularize them into that single multicast, and essentially this device is going to be needed when you have things that match the architecture of the simple transmitter and the simple receiver and no way to funnel them into each other. And that's basically, again, still a very low data rate. It's all in software. You can put a pretty much unlimited number of channels in one hardware architecture, but you may need that level of extra modulation. And here's an example why that might be even more concrete. Because you're probably, even just in subtitling, going to have to take data from different sources and make sure it works together. Because most broadcasters are going to have some combination of pre-recorded material that has subtitling already on tapes or files, and then live material that's going to have subtitling live inserted. So one possibility is to use a system like ISO 5 to be telling the receiver, read from this device, no, now read from that device, essentially on the automation schedule. But if you want to have one continuous multicast stream to capture that always contains the captions for the channel, then you're going to need to have something that works in series, more like a current SDI caption encoder that takes upstream data and is able to multiplex that with live data based on a set of business rules or a schedule, and is then able to put out a stream that represents the continuous captions for the whole program and for all of the programs inside the schedule. How are we doing on all this? This 211040 was the last of the 3 Essence standards to be finalized. It was approved in March 2018, so about a year and a half ago. And since then, there have been a lot of vendors implementing the standard with a good amount of operability, so that's very good. We saw 27 products at the JT&M Tested event in Germany last month, passing a 211040 transmitter validation, which basically means the packets that they were putting out, which was a program of the vendor's choice, essentially, with subtitles and time code, is passing an automatic validation test that this is readable, that this has appropriate timing to be reconstructed into SDI video signals, and that everything in the packets can be decoded and played out on something like a multi-viewer. And we did see that now, at that event, there were probably about half a dozen different multi-viewer and test and measurement products that could read the OP47 subtitles as well as the 608-708 North American captions. So that's a big improvement over where monitoring on this was a year and a half ago. And it allows us to look at those transmitters. We also have 29 products showing that they can receive 211040 signals. And the products were allowed to demonstrate that in a variety of ways, either by being able to represent the captions on the screen, being able to represent the time codes on the screen, being able to show some type of a packet dump. So that all comes into just the fact that what the test is for is to make sure that they're receiving the data over the network, because of course different ancillary data applications are going to be used in very different ways depending on the nature of the receiver. So we're starting to see commercial adoption of this, which is really cool, with the existing captioning standards. And some things that are kind of on the next page for this is to say, there's a standard in development, 211041, that's kind of early in the cycle, and it's looking at new metadata that can be put in that may not match up with existing ancillary data, but is going to be registered through SMPTE in a similar way. Other ideas being floated are doing things like having a TTML track that's also something that's on a standards track, and having TTML and RTP, and that could be put in the 2110 timing base, and really you could say that some of these important applications like subtitles, maybe it needs to be more than something that's in an opaque bucket of different types of metadata, and needs to be on its own track with its own receivers, and that can be logically handled with the same multicasts. For now, even with the existing ancillary-based solutions, you have a solution that is sensibly back compatible with gateways, and we have all of these advantages of moving away from something where we have to have SDI, just for specialty applications like a closed caption and subtitle encoding. Instead, it's going to all fit on the software stack of the other 2110 applications. So that's all I have, and I think we ran short, so we need a lot of questions. Paul.
Sorry, I missed. Go ahead.
So 2110-40 allows you to put one service per payload, or you can group services within. Can you just talk about the confusion or lack thereof with that problem or opportunity?
Yeah, I mean that's going back to, I think, this diagram, which was at the core of the most confusing part of the slides, no doubt. Yeah, there's again, to Paul's point, a lot of fielded devices now, they have this problem where they are the simple transmitter that can transmit a 211040 stream. It could have one DID, or it could have multiple DID SDIDs, being the identifiers for this data. And what it doesn't do is do this thing with the brown boxes, where it doesn't take upstream data and merge it with local data to make a combined multicast with all of the data. And then we have a lot of fielded boxes that are the simple receiver, which would require another box to essentially create a combined stream of all the relevant types, and at least for SDI down conversion, be able to make sure they all have, row numbers and packet types, and that align and that don't conflict. It's really an undefined behavior, I think, when all those things conflict. So, hence, you do have the concept of probably needing, in a complex plant with a lot of VANC types, something like this, VANC funneler that's going to put it all into a single multicast.
Oh, yeah, sure, on the tape. So this is maybe an engineering guideline or a recommended practice that simply should be looking at as we get more experience with this.
Um, uh, yes, I think it'll become clear as people do more complex deployments that this is a problem that is not so well addressed yet.
Hold on.
Hi, you had the diagram up there I was going to refer to. So your, no, the one that you had. Are you thinking that the sidechain keyer could be like a separate device or a separate process?
Well, I think it would often have to be separate software unless simply, if one of these other devices was capable of this, I mean, for example, the EEG caption encoder is basically capable of this behavior. So if one of the devices was capable of this behavior and you put it essentially last in the chain, then you don't necessarily need a completely independent device to do this, but you probably do need at least one device there that has this sort of behavior. Again, because the alternative to having that device that has this type of behavior is that every receiving device that you plan to use needs to have the behavior of having multiple user input fields for multiple did, SDIDs, and some sensible logic for when conflicts are found in packets from different sources.
So what is your understanding or expectation about the PTP timestamp of what the sidechain keyer is sending? Is it keeping the timestamps from those multiple inputs, or is it when the sidechain keyer is sending that packet?
Well, so that goes into, I think, more general questions about when you restamp timestamps versus when you're going to, reclock them on a new frame boundary. And I mean, either behavior might make sense depending on the context. If these simple transmitters are basically in good sync and you're going to pick them up off the network and put them out together pretty much immediately because they're all in the same part of the field, you might essentially be adding a delta to that. There's been discussion of how that could be signaled in an SDP file, and that might be what you're doing. And at that point, you've kind of moved the real now time. The packets are getting slightly farther behind that, where the alternative would be, okay, things are waiting an entire frame boundary. And if you have no assumptions whatsoever about where the Vank and Hank data could be in the frame, you are almost stuck with that frame delay issue, because you don't know when they're going to stop. These different transmitters aren't all going to signal at the same time the end of the frame until the end of the frame. So
Good question. Okay, any other questions? Yep.
Hi, thanks for that, Bill. That was really good. That was really a really great summary, and it made a lot of sense. I just wanted to speak up about the idea of subtitles and captions being a separate form of essence. You
deserve much credit for this idea. So
well, I'm Nigel Meggett from the BBC, and I've had a bit of a hand in helping some of the other guys in the BBC put together the IATF spec for TTML and RTP, and I very strongly believe that it is a sort of first-class kind of media in its own right, and we should start to process it. But I think what you really clearly highlighted there is the sort of the difference between the current way of doing things and the current assumptions with the current kind of payload types versus if we move to TTML. So none of those standards, as far as I know, currently, there is no way, nobody puts TTML in SDI. So if you're tied to a world where you want to put stuff in SDI, then you don't want that in 2110-40 because it's not going to help you. You can't do anything with it. But if it's a separate thing altogether, then maybe there is a sort of parallel path that you can go through. Thanks for...
Yeah, and so to discuss a philosophical idea in captioning, obviously captioning and subtitling is, it's called metadata in most of the standards. It is in fact, philosophically, I strongly think it's more of an essence. It's like it's like another audio track is really what it's more like. And, so there's some sense in handling that way, even though that hasn't been the traditional way of doing things. Could you tunnel TTML through SDI in a Vank packet if there was a desire to do that, I mean, of course you could. It's not like it's such high bandwidth, but yeah, that's not really currently standardized.
Any other questions? All right, Bill, thank you very much.
Okay, thank you, everyone.
Okay, folks, that's it for today. If, again, go to vsf.tv if you'd like to see a link to the video presentations or the VSF channel on YouTube, and scan your badge at the door for to get on our list to get the link to the presentations when they're posted. So thank you very much, and we'll start again tomorrow morning at 10 o'clock. Thanks.